Hello guys, welcome to Placeboard to Edu and my name is Vinay Kumar Nayanabhadrani. In this module we are going to do some problems based upon the resistors. What are the problems on that resistors? I am going to do the series and parallel combination of resistors. So let's get started. In all the problems, what we have to do is find the current, voltage across each resistor and current through every resistor when the voltage source is 10 volts. Okay, this is what the this question is common for each and every problem I'm going to discuss. Okay, so the voltage here is 10 volts, right? What is this connection? In order to do that, we have to find the terminals of resistors. So for the, let me name these resistors. This is resistor 1 and this is resistor 2. For resistor 1, these are the terminals, right? I'm writing as 1 dash and 2 dash with blue color, and for resistor 2 it is 1 dash and 2 dash, that is with yellow color. Both 2 dash and 1 dash are joining at one point, therefore it is these resistors are in series connection. Okay, for better understanding I have given the link in description and icon. You can see that video to understand this technique which I am using to find whether the resistors are in series or parallel. Okay, so I got now resistors are in series. When resistors are in series, I've already said that R equivalent will be R1 plus R2, right? We have R1 is equals to 10 ohms and R2 is equals to 10 ohms. Therefore, R equivalent is 20 ohms, right? So we have the R equivalent as 20 ohms. And also, since the source is 10 volts, we have V as 10 volts. So the I through each and every resistor will be I is equals to V by R equivalent, right? Am I correct? Yeah. So V is 10 volts and R is 20 ohms. Therefore, I is equals to 0.5 amperes. I is equals to 0.5 amperes. So, since these two resistors are in series, then I1 will be 0.5 amperes and I2 will be 0.5 amperes. If you are following my videos, and you will be easily understand this step, because I have already told you that in series connection of any components I will be same. Now we have to find V1 and V2, right? So for finding V1 we have a formula, that is R1 by R1 plus R2 into V, that is 10 by 10 plus 10 into 10, right? That is 5 volts, and the same will be the V2. So I have V1 is equals to 5 volts and V2 is equals to 5 volts. I think all these conditions are satisfied. That is, we found the I through each and every element and V across each and every component. I have to tell you an important point, that if you observe, two resistors are of equal magnitude, right? This is 10 and this is 10. And so the magnitude of voltage will be exactly equal to half of the voltage which we are applying to that, right? We have applied 10 volts to the combination of 10 ohms and 10 ohms in series, then the voltage will be half of the applied voltage. So I'm going to write here some conclusions. whenever two equal resistances are in series, then voltage will be V1, V2, both will be equal, and that is equal to V by 2. This is important relation. Okay. And the next thing is R equivalent will be 2 into R1 or 2 into R2. Since R1 and R2 are equal, we have R equivalent is equals to R1, R2. Okay. This is particularly for two resistances, but when n resistance are there, then V1, V2 and so on, Vn will equals to V by n, and R equivalent will be n into R. R is nothing but the resistances which we have given in the circuit. Understood? These are the important results which you have to take care of. Okay, that's very important thing you have to understand. See here, these are the important results you have to remember. These will be useful for the calculations. This is important. Okay, next, again I'm writing the voltage source, that is 10 volts, and I have to find this one, I1, I2, V1, V2 and total I. This is what we have to find, right? Now the terminals are, I'm giving with blue pen, that is 1 dash and 2 dash, and with green one, 1 dash and 2 dash. If you observe, we have two joints, right? Therefore the given resistance are in parallel condition. In parallel condition, we already know that V1 is equals to V2 is equals to apply voltage. That is V1 is equals to V2 is equals to 10 volts. Understood? And what will be the R equivalent? R equivalent will be R1 R2 by R1 plus R2, right? So 10 into 10 by 10 plus 10, that is 5 ohms. And I1 will be equal to I by 2, which is equals to I2. Then what I is? I is equals to V by R equivalent. What is V? 10, and what is R equivalent is 5, 5 twos. Therefore I is equals to 2 amperes, I1 is equals to 1 ampere, which is equals to I2. Since both the resistances are equal, we have two equal currents flowing through them. So I1 is equals to 1 ampere, I2 is equals to 1 ampere, and I is equals to 2 amperes. This is okay. I want to give you the generalized statements for this. Okay, let's see. Whenever two equal resistances are in parallel, then I1 is equals to I2 is equals to I by 2. Okay, and R equivalent will be R1 by 2 or R2 by 2. This is just for the two resistors. Okay, what if n resistors are there? What if n resistors are there? For that I am writing here, if then I1 equals to I2 and so on, In is equals to I by n for n resistors. Similarly, R equivalent will be equal to R by n. These are the most important relations you have to observe. It's better for you to note this down. Next one. See here, I am giving the voltage source, that is 10 volts and 10 volts. whenever there is a circuit combination with series and parallel, first try to give priority for parallel. First see the parallel and second series. Okay. Now I am going to see the parallel condition. 10 and 10 are in parallel. So we have to recall the rule that whenever two equal resistors are in parallel, then the equivalent resistance will be half of it. So 10 and 10 are the resistors which are in parallel. So the equivalent resistance will be 10 by 2, which is equals to 5 ohms. Observe that I'm considering only one resistor, not two resistors. Some people will do like this 10 plus 10 by 2, which is a blunder. Okay, you have to consider only one resistor, that is 10 by 2, which is equals to 5 ohms. So our circuit became like this: 5 ohms and 10 ohms. We have 10 volts here. This is positive, this is negative. I didn't mention any positive negatives there, but I considered left side as positive in previous examples. Okay, no issue. And now I have to find the R equivalent. It is very clear. R equivalent is nothing but series resistances, which series R equivalent is nothing but 5 ohms and 10 ohms in series. That is 5 plus 10, which is equals to 15 ohms. And I is equals to V by R equivalent, that is 10 by 15. That's enough. No need of simplification. And if you want to simplify 2s, 5 3s, it's 2 by 3 amps. And what else? The voltage across these things, right? The voltage across V5 ohms and V2. That is very simple. That V1 is equals to R1 by R1 plus R2 into 10 volts, right? R1 will be 5 and this is 15 into 10. 5 ones, 5 threes. So 10 by 3 volts. And similarly V2 will be 20 by 3 volts. The addition should be equal to 10. That is V1 plus V2 should be equal to V, right? And it is satisfying here. We have I is 2 by 3 amps and we got V1, that is 10 by 3 volts, and V2 20 by 3 volts. Understood? From here, what is the result you have to take is, whenever resistance is more in series, whenever resistance is more, the voltage across it will be more compared to the other resistor. The component which has more resistance will have more voltage across it when in series connection. That's what the result you have to take from this example. Okay, next one. See here, I said whenever we have the combinations of series and parallel circuits, you have to first take care of parallel. Do we have any parallel circuits here? Yeah, this one is a parallel circuit. Two equal resistors are in parallel. So 20k by 2 will be 10k, right? And I'm giving here 10 volts. This is positive, this is negative, no issue. And the next thing, do we have any parallel circuits? Yes, here is another parallel circuit. But the problem is we have a series circuit in it. So first we will solve it. Series circuit. Two equal resistors are in series. So the resistance, equivalent resistance will be into 2, right? So 10k into 2 is nothing but 20k. Now the circuit will be, I'm going to draw it. This is 15k. I have to see it. Yeah, this is 10k. This is 10k. This is 20k. This is 20k. And all are joined like this. And we have all test source, right? Yeah, this is what the circuit is. Okay, it's clear, right? Actually here I can solve all the three resistors using parallel connection, but Observing these two resistors, we have 20K and 20K parallel, which results in 10K. Hope you guys are understanding like this, which results in 10K. And now the circuit will change into 15K, 10K, and this is 10K, and also this one will be 10K, right? I'm changing this one into 10K, right? And now 10K and 10K are parallel. Again 10K by 2, that is 5K. So I got 15K, 10K, 5K. This is what the circuit became like this. Okay, the circuit became like this. So 10K and 15K is nothing but this is, these two are in series, so this is 15K, and both 15K and 15K are in parallel. Therefore we have R equivalent is equals to 15K by 2, that is 7.5K. This is how we find the equivalent resistance. We find where are the parallel connections and where are the series connections, and we reduce them to a single resistor. Hope you guys understood this. Okay, now how to get the voltages and currents of these type of circuits. Okay, how to get the voltages and currents of these type of circuits? For that here 10 volts is parallel to 15K, right? That means it is directly connected to 15K, so the voltage across this one is 10 volts. Understood? And this 10 volts is divided between this 10K and the part this one. Okay, how much is this one? I have already solved this, that is 5K. So this whole thing is 5K. This is 10K. Understood? I have already shown you the 10K, that means 10 and 5 resistors, right? Just the values are like 10,000 and 5,000. Okay, so we have 10 by 3 volts and 20 by 3 volts, right? So we have here 20 by 3 volts, and here it is 10 by 3 volts. Since these two are parallel, here we have 10 by 3 volts. Since all these are parallel, here we have 10 by 3 volts, and here also 10 by 3 volts, and 10 by 3 volts is applied to 10K and 10K, which means the voltage should be divided by 2. So this is 5 by 3 volts and this is 5 by 3 volts. In this way, by seeing the circuit, you have to find the voltages of given components. This will be possible for some circuits, but if you are good in basics, you can easily do this. I think you understood this. If you have any doubts, comment below. Hope you guys enjoyed this video. So please like, share, comment and subscribe. If you guys didn't like this video, please let me know through comments. Thank you.